Hello, everyone. I'm going to be discussing the 5 things you need to know, and we're going to go into detail about the things that you're going to have to perform in order to get everything correct on this next section. So as you can see, we're looking at this graph here. This was a graph that goes down to -2, -6. It goes up to 0, 10, and then goes down to 2, -6. The 5 things you need to know by looking at this is the degree, the end behavior, the intervals, the critical points, y-intercept, and vertex. So we look at the degree. It's the number of bumps plus 1 gives you the degree. So 3 bumps plus 1 is 4. So the degree is 4. It is an even. End behavior, as you look to the, that's a positive infinity. So as you look to the to the right, as you look to the right, the graph is going up, so it's positive infinity. As you look to the left, it is going up, so positive infinity. So the end behavior for both ends up being positive infinity. That would be going right here. I wrote y, but usually they always write it as f of x. Intervals. The first interval going down is going to be negative infinity. Negative infinity. So negative infinity, and the decreasing interval is going to be negative infinity to -2. Notice we don't really use the y, we only concentrate on the x when we write the intervals. The increasing interval, as I'm writing over here, is going to be from -2 to -2 to 0. And we write a little u in between as our union. And then we do the same thing on the way down, so we're going to get 0, -2. And then the final is going to be, +2, and then +2 to infinity. So that brings us to our top. And then we get to the y-intercept, which is here, 0, 10. And then we have the vertices are right here, 1, 2, 3, 4. These are the absolute minimums. This is the relative maximum because the maximum goes on for infinity up here. Remember, you can always use a vertex as -b over 2a. That being said, we have a couple more examples. Even, positive, as it goes to the right, it's positive infinity. As it goes to the left, positive infinity. In another example of intervals increasing and decreasing. And then that brings us to what we went over yesterday, which is analyzing a graph. We have here, we have the vertex pops out at you. So we have 7, 5, -3, -11. The rule is you always take the opposite of the h, and that becomes your vertex. More things we went over last class. For those of you who missed it, we talked about those shifting or the transformations. As it's a fraction, usually it'll get tighter, and as it's a fraction, it gets stretched out. Ooh, that's over here. It's kind of hard to see it. It's behind this picture of me. It's the green. The red is the number is greater than 1. And that means transformations is just simply a way of saying what is happening to the graph. So here's a good example. Notice how it says it's going to, we have the terms here for reflection. That means this is negative, reflects over the x-axis, and then it moves to the right 5, even though it says -5. It's right 5 and then down 3. We went over all these. We did a couple for homework, and I gave you 6 of these for homework. 1/2, as it gets wider because it's a fraction. It's less, this a is next to the number in the front is less than 1. You're going to have to do the transformation, say it goes to the right 2, up 1. And that's it. That's all we added was vertex and talking about it in words. Merry Christmas.